In this video, we're looking at linear equations and some ways to solve them. First of all, algebraic equation is a statement that has two expressions which are equal to each other. When we're solving algebraic equations, we are finding the value of the variable given in the equation so that it makes sense for the given equation and makes it that true. There is also something that's known as equivalent equations. This is simply saying that no matter how your equations look like, they might have the same solutions, and if this happens, then you have equivalent equations. The most common way to write a linear equation in one variable is to represent it in the form ax plus b equals c, where letters a, b, and c represent real numbers, and a that stands in front of the variable is not a zero, and x represents the variable. Here is a list of examples. 3x plus 2 equals 8, so that's linear equation with variable x. 5t with a minus plus 7 equals a certain fraction, also linear equation, even though right now we have some numbers that are fractional. 8 times y plus pi equals 79. Now this one is linear equation, even though there is a letter pi standing in this equation. It's actually a number 3.14 that's very well known in mathematics. And letter y will be our variable. And finally, 12c equals 100, also a linear equation, even though it has only a part with the variable and the right-hand side number, it's still a linear equation that we can solve. In solving linear equations, which means finding a number that makes the statement true when we plug that number inside of the given equation, we're going to use two properties. The first property is known as addition property of equality. So this property is simply saying that if you have an equation, something equals to something, and you need to change it and help you to solve it, you can add or subtract the same number, but it has to be done simultaneously to the left and to the right side of your equation. Another property called multiplication property. This is very similar to the addition, but if you can guess, it's just multiplying or dividing the given equation, such as a equals b, by the same number on the left and right hand side of the equation. Every time when you have equation in front of your eyes, no matter if it's linear or not linear, these two properties are very helpful in solution steps. Now, to solve the linear equation in one variable, we can follow certain basic steps. They are very common steps, and if you follow those steps, they will help you to solve pretty much any linear equation. So first step, we need to clear the fractions. Fractions are very tricky to work with. Number two, simplifying each side of the equation. And to do that, we can distribute everything that's possible and also combine like terms on both sides of the equation. Third step is making sure that all of your variable terms will be on the one side. In this, we're going to use addition property of equality. So we're going to add something to both sides or subtract something to both sides. Step number 4 is using multiplication property of equality. This is when you divide or multiply both sides of the equation so that you have variable just as the letter without any coefficients in front of it. And finally, always check solution by substituting whatever you have as a possible answer in the original assignment before you made any changes described in these 4 steps. So let's practice. In the first example, we have no fractions, so obviously we can skip this step because it's not necessary for us to clear fractions. But we do have some parentheses going on in this example. So we're going to open up the parentheses, also known as distributing property, and see what we can simplify. So now we opened up the parentheses, and there is one note that I want to underline, and that's when we opened up the second parentheses with 8z and 9, we changed the sign to the opposite from what was in the assignment. So now we have negative 8z minus 9, because minus in front of the parentheses changes everything inside of the parentheses to the opposite sign. Next, we're going to combine like terms, and that brings us to the 3z with a minus, because 5z minus 8z is 3z with a minus, and then 15 minus 9, those are two like terms as well, so that gives us 6. We didn't make any changes on the right-hand side of the equation. Now we want to combine or modify things in the equation so that all the variables are on the right or left-hand side of the equation and the rest of the elements on the other side. To do that, we're going to add 5z to both sides. So we're using addition property and trying to make all of the variables of the z value to the left-hand side. So that will bring us to the expression 6 plus 2z when we combine like terms on the left and 0 on the right side, because we have 5z with a plus and 5z with a minus. Now we're going to use again the addition property and make sure that the number 6, because it doesn't have a variable next to it, is located on the right-hand side. So we're going to subtract 6 from both sides, or also known as adding negative 6 to both sides. Both expressions are equivalently correct. Now we simplify again by combining like terms, and we see that the expression right now looks like variable is on the left side, and constant term, which means it doesn't have a variable, is on the right-hand side. So we are to the final step for us, and that's using the multiplication property. So we're going to clear the variable z so that it has no coefficients in front of it. To do that, we're going to divide both sides by 2 simultaneously and simplify the expression. So that will give us the answer, z equals negative 3. So that's our possible solution. Now we have to do one step, and that's checking. Let's do this at least once so you know how this procedure works. So we're going to take our possible solution, and we're going to substitute this value, which is negative 3, into the first line when we first saw the equation for our example and before we made any changes. So if we substitute negative 3 instead of every z value that we have in the original equation, we're going to get parentheses with negative 3 and positive 3, parentheses with 8 times negative 3, and then right-hand side with multiplication of negative 5 and negative 3. We're going to simplify using the order of operations both sides, which means we're going to do parentheses first, and then multiplication and division and addition and subtraction. So in parentheses, we have for the first part 5 times 0, for the second negative 24 and 9, and then negative 5 and negative 3 is 15. Moving forward, we have 5 times 0 is 0, negative 24 and 9 in parentheses is negative 15. So now if we simplify the left-hand side of this equation or expression one more step forward or further, we're going to get 15 equals 15, which is a true statement. And this is telling us that what we found is indeed a solution for this linear equation. For the second example, we can look at the simple equation that is linear in form, but it does have fractions. This is somewhat special because we have all the variables on left side and number that represents constant term on the right hand side. So we don't have to do any parentheses, distributive properties, or other steps. So we can directly jump into the step of multiplying or dividing both sides so that we can get rid of 1 over 7 in front of the letter x. So what we can do is use the idea of reciprocal and multiply both sides by fraction that's upside down of what we see in front of the x. That will make it easier for multiplication purposes on both sides of this equation because we have a lot of fractions, and multiplying fractions is always easier than dividing them. So if we multiply fraction on the left-hand side, we're going to get across 7 times 1 for the numerator and 1 times 7 for the denominator, which is 7 over 7 or just 1. And then on the right-hand side, we're going to multiply across numerators 5 times 7 and denominators 9 times 1. So that will clear all the fractions, and element of variable x will be standing on its own on the left-hand side. So this is our answer. Even with this simple equation, by using multiplication property, we managed to get this 35 over 9 in one step. Moving to the next example, we're going to see a combination of everything: a fraction, parentheses, and no parentheses, no fraction on the other side. So we're going to go over all those steps that we saw before. So we're going to clear fractions, and this time it's necessary. We're going to use distributive property if needed, because we have parentheses. It's probably going to be a good idea to use this property. We're going to combine like terms. We're going to get all the variables on one side, preferably left one. Simplify the answer if needed, and then check the solutions. So first is the view of this equation and finding the way how to clear fractions. The only technique that works best in here is to use the least common denominator. Now the denominator for the first fraction on the left is 5. The denominator for the second fraction on the right is 1 because we have nothing written in here. So that is 1 as a denominator. So when we look at the common denominator between 5 and 1, it gives us LCD 5. So now we're going to use this least common denominator and multiply by that number both sides of this equation, left and right. So again, we're using multiplication principle and doing things simultaneously on both sides. So that gives us a chance to reduce on the left-hand side because all the additions are carried in parentheses. And 5 on the right-hand side will stay with us. We're going to use it later as a distributive property, which gives us 10y plus 30, which is 5 times 6. Now on the left-hand side, since we were able to reduce by 5 the numerator and denominator, when we use the distributive property, it leaves us with 3 times y and 3 times 3 only. Now we're going to use the idea of addition so that all the variables are collected on one side. So subtracting or adding negative 3y to both sides will help us to move all the variables to the right. And we're going to get 7y. And then to do the next step and move all the numbers to one side, we're going to add negative 30. So that brings us to the expression 9 plus negative 30 equals 7y, and 30 minus 30 gives us 0. So that is negative 21 on the left, 7y on the right. And then to get rid of the 7 in front of the variable, we're going to divide both sides by 7. So this time we get the variable equals to negative 3 as our possible solution. The best way to check it is to substitute that number in the given original equation. Among all the equations that are linear in format, there are some equations that need special attention. Even though they look like a regular equation, when we solve them, we have something unusual at the end of solution steps. So let's look at a couple of the examples. This equation, 3x minus 7 equals 3 in parentheses x plus 1, looks like a regular nice equation without fractions. So we're going to use distributive property and then try to combine all the elements that have variables on one side. So we're going to subtract 3x. When we do that simultaneously on the right and left and reduce everything and combine like terms, we observe that the variable disappears completely. Now that's one of the specialties of such equations. The variable disappears completely. So it looks like we have nothing to solve for. However, since we started with the equation, we're still able to make a conclusion about the solution of this equation by looking at the final result of our steps, and that's -7 equals 3. So if you think about it, -7 and 3 are not equivalent numbers or not similar numbers. So we're going to say that this statement is not true because -7 is never equals to 3. And in such statements, every time when you have the outcome that's not true, you're going to say that the original equation has no solutions. Sometimes such equations are called contradictions. Now let's take a look at another one. We're going to use the same set of steps as we did before. We're going to open up the parentheses, combine like terms, and we observe right away that this equation has two sides, left and right, that are absolutely identical. Even without continuing our solution process, here is the conclusion that we can make. So this is a true statement, and such equations as the answer will have all possible numbers or all real numbers as solutions. They are also known as identity equations. Now, if you don't observe this statement as equivalent on the left and right side, you can continue solution steps and subtract 5x from both sides and then subtract and add 5 to both sides, but you will end up with a statement 0 equals 0, which is true. So you have two numbers that are absolutely identical on both sides of the equation. So this time you can make a conclusion that the solutions will be all real numbers and it is an identity equation. And finally, a little note about 0 itself as a solution. So if we look at this equation that's linear in form, 5x plus 2 and 2x plus 5, use the distributive property and then try to solve it, we're going to need to move variables on the left and numbers on the right. To do that, we need to subtract 2x and add and subtract 10 from both sides. So this will bring us to the equation in the form combining like terms vertically. That is 3x for the variables on left, equal sign, and 0 on the right. Now we didn't lose the variable this time, so we still can continue the solution steps. All we need to do is divide both sides by 3. This is a perfectly normal division, and when we divide 0 over a number, it's totally mathematically okay to do that, and the answer will be variable, equal sign, and 0. So this time we didn't lose any variables, we moved through all the steps, and our solution is just 0. So that will be the answer, x equals 0. And in order to check it, we need to plug in that number in the original equation if we want to do the checking step. So as a summary, when you're solving linear equations and going through all the steps that are basic steps mentioned in this video, here are the outcomes that you can expect. You will have one solution that's non-zero. So you can get any number that's real number in fractional form or non-fractional form, but it's going to be one number. And here is an example with the solution -4. You can also get one solution that's actually 0. We just saw that example, and here is an example in addition to what we saw before, and x that does not disappear, it stays in the equation, and the answer is x equals 0. Perfectly nice number, and that will be the solution. Another option when you have all real numbers as a solution answer. So this is when your variable disappears, but at the end of your solution steps, you have something that looks truthful, and that is 0 equal to 0 or 5 equals 5 or something similar. And finally, no solutions. This is when after all of your steps, you end up with a statement that's non-truthful. For instance, -2 equals 0, or maybe 5 equals 7. So something that doesn't have the same number on both sides.